This is a beautiful, easy to read test assertion. But how did I get there? When the starting point is something like this, the secret is asking, how would I express this assertion using domain-specific concepts? And once I have the answer for that, I just need to find a way to express that using my assertion library. Likely you already know that I'm a huge fan of Fluent Assertions. And the good news is that Fluent Assertions is highly extensible. This is the starting point of this example that will be refactoring in order to simplify all this assertion part, everything that you can see right here. So what does this example has at the moment? We have here this simple test, we are using XUnit, and also we have here this model folder where you can find an order line, and a product. And on this test, we want to make sure that every single time that we call the add product method inside of the order, all of those products that we are adding and the correct quantities are added as an order line in that order. This that I explained to you is basically what is happening right here. So if you look into this complex assertion, you can see that we are looking into the lines, checking if a given product name is there, and then checking if for that product we have the correct quantity. And for that, let's create a new test so we can keep the before and the after so you can compare it. This will be our after test. Everything that we are doing right here is exactly the same as we are doing in the before. And now we want to start writing our assertion. So using Fluent Assertions, you usually go into the object, the result that you want to assert, and we'll call the method .should. If we do that, you can see that I already have here some assertions that I can add on top of my test. For example, I can check if it's not null. But I want something more. I want that when I do the .should, I want to use methods that say something to me. For example, on this case, I want to be sure that this order contains not only the product, but the product in the correct quantity. So I can imagine something like this. I will say .should, .contain product, and I will specify the product name that I'm looking for and the quantity that I want to assert. And how do I bring this thing to life? I will create a folder named Custom Assertions, and there I will have a class order extensions. And this class is extending the order and with the name should, the name that you already recognize from the other example. And I'm also returning this order assertions thing that I will need to create. So let's do that. To make this code compile, I need to have a constructor that will receive the order, and we can introduce a field. Now we can add the contains product method that we want. So the contains product will have to return this end constraint that will help us to chain multiple assertions using Fluent Assertions. And then I'm receiving the product name and the quantity. If you go now to the test, you will see that now our contain product is already compiling. Okay, my IDE is already recognizing this line. But now I have an error here, and how can we fix that? Since this extension method, the order extensions, is returning these order assertions, and the order assertions doesn't contain a not null assertion, I can't use it. So what can we do instead when we are using Fluent Assertions? If we inherit from the reference type assertions and we provide the type that we are extending and the order extensions, that is basically this one, now we will have access to those other assertions. So it's quite simple. You just inherit from that. We change the constructor, so we don't need this private read-only field anymore. And we override this identifier that will be used when we are building our messages, and we'll see that in a moment. If we go now to our test, we can see that the not be null is already compiling, and the contain product is already compiling as well. So let's make this contain product do something useful. Fluent Assertions exposes this execute.assertion that will give us access to the engine, and we will inject into there our conditions that we want to apply, our constraints. And we can start by doing the following. For example, I'm saying here the because of, and I will provide these two arguments that I'm receiving right here. We'll see that playing out in a moment. Then we can specify conditions. For example, I'm defining here that if the product name that I'm receiving is empty, this assertion isn't valid at all. And the fail wave is the place where you can define the message to be returned to your user when he's running the tests. Once that execution failed, that for condition failed. Here we are validating the input of that assertion. So let's make this thing do something useful. To do that, we can start chaining other conditions on top of this one. Well, how can we do that? We will use the then, and on this case, I'm using this for condition to check if my order has lines. To do that, I can access to the object, the author, through this subject. This subject will have the instance that you provide here when you are constructing these order assertions. Now that I have specified my for condition, I can define the message that I want to see if this order has no lines. Then we keep doing the same thing. We use the then to chain another condition, and on this case, I will want to define the condition that will check if that product is inside of the order line. I want to reduce my subject to be the scope of the following assertions that I will be applying using this expression. So I can use this given to use a selector, and from that selector, I will get the thing that I want to pipe into the following condition. On the next for condition, you can see that I'm receiving here a collection with order lines. Why? Because I defined that given. On this condition, I'm basically checking if there's any line with the product with that name that we are looking for, and now I can define the message that I want to see if it fails. And let's take some time here to see how this message works. Let's run the test with an invalid value that is not inside of the collection to check the message that we'll get from it. From the error message, we can understand that this context.order is in fact the identifier that we provide inside of our order assertions. We can see that this 0 is the first argument that we are providing in the parameters list, that is right here. The 1 will be the list that we are providing here with the list of products that are inside of the order. And then there's one extra more, that is this reason. The reason will come from this because of. So the because of is receiving the because and because arguments that come from our method. So when we define the assertion, and then you can define a message with arguments that then you can provide those arguments in the because arguments list, like this. Once we run the test again, we can see that now we have this extra thing right here that will explain exception. To complete our assertion, now we want to check if the quantity is exactly the one that we are looking. We could change this assertion that we have right here to make sure that when we check for the any, we're not only checking for the product name, but also that the product and the quantity match. But if we want to provide messages that are really targeted to what we are doing and they are kind of progressive, so if you fail for example, because of the product, you have a specific message. If you have the product there, but the quantity is not correct, you have another one. Then you can start chaining even more conditions on top of it. So using the same tools that we have been through, we have once again a then, we have a given. On this case, the given is looking for the specific product that we are looking for. And then we go to a for condition and we use the fail with to give a different message. Now, if we put side by side the two expressions, the before right here and the after right here, I think we can agree that the one on the right side, the one after all this refactoring, is more expressive. We have the domain concepts there. We don't have a huge cognitive load to understand what this assertion is doing, with the benefit that for sure you will not be only checking if a product is inside of an order only once inside of a single test. So you can reuse this extension that you built across your multiple tests. So what do you think about this approach? Leave a comment with what do you think. Will you be using it? Do you have any question regarding using it? And if you have been using Fluent Assertions or you plan to start using it after seeing this video, make sure you watch this one where I show you 3 features that many people don't know about Fluent Assertion and I really like that. I will see you soon, and in the meanwhile, keep it simple.